Is your Arduino project lagging? You press a button and it feels like it's taking a nap. You spin a knob and it misses half the signals. You start to think your Arduino is just too slow, but it's not. In the next 10 minutes, I'm going to show you the simple fix to make your Arduino 10 times more responsive. This one technique will let you build projects that react flawlessly. No, more lag. But before we dive in, a quick, honest request from me to you. If you get any value from this video, please take 1 second to hit that like button and subscribe. It sounds like a small thing, but for a creator, it is everything. It tells YouTube that this video is helpful and lets me keep making more content for you. Plus, I read every single comment. Your feedback, your ideas, your questions, they directly shape what I make next. Thank you for being a part of this. Okay, now let's make your projects instant. Alright, so this is how most of us learn to read a button. It's called polling. Think of it like a kid on a road trip constantly asking,
"Are we there yet?"
Your main loop has to repeatedly pause everything it's doing just to check the state of that pin. Now, for a super simple program, this works just fine. Look, we have our loop checking the button. We press it, the LED turns on. It feels responsive. Easy, right? This is a trap. And I'm going to show you how this trap completely breaks your project the second it starts doing any real work. What happens when your Arduino actually has to do something? Let's simulate your Arduino being busy. This function here just wastes a bunch of time, pretending to calculate sensor data or update a display. Now, watch what happens. The task is running, I'm pressing the button, nothing. The Arduino is completely blind to my presses until that long task is finished. Any signal you send during that time, gone. This is why projects can become laggy. So how do we fix this? How do we guarantee no missed signals? The answer is a powerful tool called an interrupt. You could stand by your front door all day, constantly checking if someone is there. That's polling. Or you could go cook dinner, watch a movie, and when the doorbell rings, you immediately pause, answer the door, and then go right back to what you were doing. The microcontroller does the exact same thing. The doorbell ring is the interrupt. You should use an interrupt for any event that is fast, infrequent, or critical. Button presses, rotary encoders, sensor triggers, they are perfect for this. And we make the magic happen with this one function, attach interrupt. It needs 3 things, the pin and warning. Only certain pins can do this. On an Arduino Uno or Nano, it's pins 2 and 3. Always check the manual for your board. The ISR, this is the name of your special answer the door function. The mode, when should it trigger? When the button is pressed, released, you choose. For a button press, rising is perfect. Okay, time to see the fix in action. On the left is our broken, laggy code. On the right is the new interrupt code. Look at the loop. All the button logic is gone. It's free to do other things. All that button logic now lives in this special function, our interrupt service routine, or ISR. Now, for the moment of truth. Boom, it works, every single time. The Arduino is busy in the main loop, but our interrupt doesn't care. It gets the signal instantly. This is how you unlock the power of Arduino interrupts to build more responsive and reliable projects. Using interrupts is a superpower, but with great power comes a few golden rules. Breaking these will cause the strangest, most impossible to debug problems. Rule 1, keep it fast. Your interrupt freezes your main program. Your goal is to get in, maybe flip a variable, and get out in microseconds. Be a ninja. Rule 2, no heavy lifting. Never, ever, ever use delay or serial print inside an ISR. They rely on the very timing system that the interrupt has just paused. Your program will crash or hang. Don't do it. I'm serious. Just don't. Rule 3, use volatile. If a variable is shared between your ISR and your main code, you must add this volatile keyword. It tells the compiler, hey, this variable could change at any random second. This stops the compiler from messing up your code. If it's shared, it's volatile. Rule 4, debouncing is still your friend. Physical buttons are noisy. One press can look like a dozen tiny presses. A simple check inside your ISR to see if enough time has passed since the last trigger will solve this and make your inputs clean. What if we need to watch a fast rotary encoder to control this servo and a button to control this LED at the same time? With polling, this would be a nightmare. But with interrupts, it's effortless. We just attach a second interrupt, one for the button, one for the encoder, each with its own ISR. Now, let's run it. The main loop is constantly busy. But I can spin the encoder, perfect. I can press the button, perfect. Both at the same time, flawless. This is what makes a project feel professional. No missed signals. And there you have it. You now have the secret weapon to create projects that react flawlessly to user input. Polling is simple, but it breaks the second your program gets busy. Interrupts are the professional solution. So here's my challenge to you. Find one of your old Arduino projects that feels a bit slow. Take one sensor or button that you're polling and convert it to an interrupt. I have put all of the code from this video, including the Platform.io projects and Wokwi simulations, on GitHub. You can run the simulations in your browser for free. The link is in the description. Go try it out. Thank you so much for watching. Let me know in the comments what awesome responsive project you're going to build next. Go and make something amazing.